Hello ladies and gentle ladies, and welcome back to another Minecraft modding tutorial for Forge 1.20. And in this tutorial we're going to be covering energy that we can use in our block entity. So let's go ahead and get started. So I've already created the basic stuff. So I've created our block class here. I've done the use method so we can open a GUI that will display how much energy we've generated. I've also created the onRemove so that it will go ahead and drop our inventory, since we're going to be using fuel to generate our energy. And then I have created the block entity. So I've just made it a menu provider, of course, and it is tickable. I've got our just basic capability stuff, all of this in here. Just the normal stuff that we've done in the previous block entity tutorials, really. So the only prerequisites for this tutorial are going to be the block entity tutorial, of course, the synced data tutorial, the item capability tutorial, the screen tutorial, and the menu tutorial. So that's quite a lot, but that's how much is going to be required for this. So I've just created all of the basic stuff, really. I'll show you the menu as well, and then I'll also show you the screen. So I've created the menu here, just a basic menu. All I'm doing is adding a single slot in here. So index 0, 44, 36. Quick move stack, obviously had to change this to 37 instead of 63, since we only have one slot, so we do 36 plus 1. And obviously make sure you change stuff like this if you're copying from your previous one. And if we go into the screen, this should just be a nice and simple, very basic menu screen. Nothing too special going on in here. Obviously make sure you've gone ahead and binded your menu type to your screen, and you've registered your block and registered your block entity and registered your menu type. So menu in it, here you go, I've registered my menu. Item in it, I've registered my block item. Block in it, I've registered my block. And block entity in it, I've registered my block entity. So once you've done all of that, I might have missed something, but I don't think I have. Then you can move on, and we can actually start creating the energy. So energy is actually going to be super simple. So let's come into our block entity class. And it's effectively going to be the exact same as our inventory stuff, but easier. So I'll show you what I mean. So at the very top, we will come and create a private final. And this is going to be an energy storage, but we will change this in a minute and you will see why. So a private final energy storage. Now I'm just going to call this energy, but it doesn't really matter what you call it, is equal to a new energy storage. Now there are 4 possible constructors that you can use for an energy storage. You see the first one takes in just a capacity, then you have a capacity and a max transfer, a capacity receive and extract, and then capacity receive, extract, and the kind of default energy. So for now we'll just use maybe the capacity one, and we'll give it like 10,000. Then we might want to say that we don't want to be able to receive anything, because this is going to be a generator. So we would put like 0 for the receive, and then we could put maybe 100 for the max extract, and then we could give it a default energy of 0. Obviously we wouldn't have to provide that default energy, because by default it would be 0. But we'll just leave it there anyways, just so you can see how that works. And then we're just going to want our lazy optional as well. So we're going to want a private final lazy optional of type energy storage. And I just call this the energy optional. But once again, it doesn't really matter what you call it. And that's just lazy optional dot of a supplier of this dot energy. So as you can see, it's basically exactly the same as our item stack handler inventory here. So once we've done those, what we can do is we can obviously save them and load them to the MBT so that they can save when we leave the game and that kind of thing. So this is going to be super simple. It's once again exactly the same as our inventory. So we'll do tutorial mod data dot put. We can say energy, and we can say this dot energy dot serialize MBT. Then for the loading, we can just do the exact same thing with the inventory. Once again, if tutorial mod data contains energy, and this is just going to be, this should be a tag int. I'm just going to say contains energy though, just in case maybe it wasn't a tag int. Actually, for us it is going to be a tag int, so we'll do that. That will be fine. But if you had some like custom energy capability, then that might be a little bit different. For us, we're not going to have that, at least for the foreseeable future. So we can just say this dot energy dot deserialize MBT tutorial mod data dot get, and we can say energy. There we go. And the final thing we need to do is in get capability here. So you see we're saying if the capability is item handler, then we're going to cast that inventory capability. Else we're just returning the super. So we just need to turn this else into an else if, and say if cap is equal forge capabilities dot energy. Then we're going to return our energy optional dot cast. And then we still want that else statement, so we're going to say else return the super dot get capability cap. Meaning that if this method is called with the item capability, then it will give us our inventory optional. If it's returned with the energy capability, or if it's called with the energy capability, then it will give us our energy optional. And finally, if it's called with some other capability, then we just handle the super logic, which I believe just gets us like null or something, because that shouldn't really happen in an ideal scenario. Okay, the next thing we're going to do is basically just copy paste these two methods right here, although we're not going to actually need them for what we're going to be doing today. You may want them for something you're going to do, so we're going to make them anyways because it doesn't really do any harm in doing so. So we'll say lazy optional of energy storage, get energy optional. We're going to return this dot energy optional, and also get energy as well, which will get us our energy storage. Okay, now to make our lives a little bit simpler, you can see here I've made a send update method, and all this will do is it will set the block entities changed, and if the level exists, it will also send a block update. We're going to need this because otherwise it will be a little bit messy later. Alternatively, what you can actually do is you can override set changed, and you could do this logic inside of set changed. That works, however, you do have to be careful that that would mean there's no way to mark it as dirty without causing an update, which sometimes is not an ideal scenario. For us, it would be fine, but I'm going to leave it like this just so it's easier to comprehend and utilize. Now let's actually do the logic for generating our energy. So what we want to be able to do is if we are not at max energy. So let's start with that. If this dot energy, and we can say get energy stored, and that will get us the amount of energy that is currently stored inside of our energy. If that is less than this dot energy dot max energy stored, which is obviously this capacity that we set right here, then we can proceed, because if we're already greater than or equal to this, then we don't want to try and generate more energy, because then we would go over the capacity. So then what we want to be able to do is basically be able to burn a fuel. And the way we're going to do that is by creating a burn time that we can count up and down from. So what we can create is a private int, and this can be burn time. And then I'm also going to create max burn time. Now you can set both of these to 0. should be their kind of starting value, and we're going to modify those inside of here. So we'll start by saying if this.burn time is less than or equal to 0. So if we currently are not burning anything, the burn time has run out, or maybe we just haven't started burning anything, then we're going to check if we can burn the item in our slot. And obviously I only have an inventory size of 1, so that means we can use get slot 0 for doing that. So we're going to say if can burn, and then we're going to pass in this .inventory .get stack in slot 0. Then what we're going to do is we can just close that bracket off there. We can say this .burn time is going to be equal to this .max burn time, which is going to be equal to get burn time, and that's once again going to pass in the stack in our fuel slot. And we're going to create these two methods in a minute, which will make this make a little bit more sense. Once we've set that burn time, then what we can do is we can shrink that stack. So we can say this .inventory .get stack in slot 0 .shrink, and we can shrink it by 1. Then finally we need to send an update so that this is synced across to the client using our sync data that we have right here. It will send this update packet, which will be received on the client, where it will load it from that MBT. So we send that update and that will sync it across. Now, if the burn time is going to be more than 0, meaning if there is burn time left on our fuel, then we're going to say this .burn time, and we can say negative negative, which will decrement that burn time. Then we can say this .energy, and we just want to receive some energy. So we're just going to receive for now 1, and we're going to set simulate to false because we want it to actually receive the energy. We don't just want to simulate the receiving. And then once again, we just need to send an update to the client so that it knows that burn time has changed, and so that it knows that the energy value has changed as well. Now, this actually isn't going to work for us, and there's a good reason for this, and you may already be able to see it. So you'll see in our energy storage up here, we set the max receive to 0, because obviously for an energy generator, we don't want to be able to receive energy from a different block entity, right? We don't want energy generators to be able to exchange energy with each other. That would be quite strange. So we set it to 0. The caveat of doing that is it means we cannot receive energy from ourselves. So we can't give ourselves energy, which is a little bit problematic, and it means that this would always just do nothing, and we would never receive that energy. So you may think instead that there would be a method set energy. However, there is not, and that is a very problematic thing, because that means we can't do it, which, yeah, that's obviously not great, but there is a solution. So what we can actually do is, instead of using an energy storage, we can create our own energy storage class. So inside of util, you can actually see I've already just created one here. So this is basically just a class. It will extend energy storage. I've created the default constructors that the energy storage has, so you can just create these. And when you actually extend energy storage, you'll see that it will try to do that. So if you say create constructor matching super, it will let you select any amount of these that you want. And then we just create some basic methods to maybe set the energy. So public void set energy, int energy. And you may just want to do some checks in here as well, of course. So if this.energy, if energy is less than 0, then you may just want to set energy to 0. You may want to say if energy is greater than this.capacity, then you may want to set energy to capacity, right? So just basically a very basic clamping function. And then you may just set the energy. So this .energy is equal energy. So that would be like a set energy method. And then you could have something like add energy or remove energy. So public void add energy int energy. And what you may just want to do is say set energy this .energy plus 1. And then we can have public void remove energy int energy. And not plus 1. We need to actually do plus energy, of course. So we can say remove energy, and we can say set energy this .energy negative energy. And that's basically all we would want for this. And if we now change this to a new custom energy storage and make this a custom energy storage, make our lazy optional a custom energy storage, we can also make our get method down here a custom energy storage, a custom energy storage. And by doing that, we can now just call add energy 1. And that will just add energy to our energy storage. Now you can obviously override methods in here too. So you may just instead want to be able to receive energy, and maybe you could override this and perform a special check in here. You'll see they basically just do the clamping there too. And you'll see it uses can receive, which obviously checks the max receive, and that's why we can't use receive energy for what we want to do, which makes sense, but it's just a little bit annoying for us. Anyways, that should be all we need to do with the energy. Let's just create these methods so we can decide whether or not we can burn an item stack. Now, this is going to be super simple since we're basically just going to be using some forge stuff to do our logic here. So I'm going to make this a public method because we might want to reuse this, and you'll see why. And in here, I'm just going to return forge hooks dot get burn time, and we're going to pass in that stack. Now, there is a second parameter here which requires a recipe type, where maybe you want to get a burn time specific to a different recipe. And if you do want to do that, you can just do like recipe type dot smelting. Alternatively, you can just provide null in here, which will get you kind of a default value. So I'm just gonna not do that, but I'm just going to use the smelting because I think that's the easiest way. In fact, let's see what it actually does. So if we come in here, you can see the recipe type, and it calls get burn time on that recipe type. So by default, that kind of gives it -1, but that will kind of change depending on the specific implementations. We're actually going to want this get burn time method first so that we can instead use that. So let's say stack get burn time. We can just return that. Now, obviously, you will see there is an error here or a warning. Now, you don't need to worry about this warning. It's basically just saying that we shouldn't be using this forge hooks class. However, unfortunately, we don't really have a choice. We can just call stack.getBurnTime of our recipe type, but I found that personally this always seems to give -1 as a result. So I just resulted in not doing that and instead just doing it like this. Now, if you want to, you can always just suppress this deprecation. It's generally not recommended to suppress warnings, but if you know what you're doing, and apparently I have spelt that wrong. Oh no, we need to suppress internal or something like that. Let's actually see what it says. So we should be able to suppress it through here. Show inspection description, API status.internal. Maybe that's just what we suppress. So suppress warnings, API status.internal. Nope, I'm not sure. There is a way to suppress it, but I'm not sure how you suppress this specific warning. So we can just ignore it. Basically, it's not really an issue for us. And yeah, that will work fine. Anyways, let's make this public too, so that we can access that elsewhere. And I'm just going to move these down to the bottom of our code as well with these methods here. I'm just going to move these down here too. So we can kind of keep these overrided methods at the top and the rest can go at the bottom. Now, the final thing we are going to need to do inside of our block entity is we need to make sure we invalidate our capabilities. So what we're going to do is just below our get capability method, we can override invalidate caps, and inside of here we just want to do this.inventory optional.invalidate, and we also need to invalidate our energy optional as well. Now once we've done that, that should be pretty much it for our block entity. So let's go ahead and move on to our menu, since there's a few things in there that we are going to want to do. So what we're going to want to do is create a fuel slot. And I briefly did talk about this in the previous tutorial where we just create a custom class for that. So let's do that. I'm just going to create a new fuel slot, and I might just call this a custom fuel slot, since so that it doesn't like collide with vanilla or anything. And I'm just going to create a new slot package inside of menu, create a class, extends slot item handler. In here I'm going to add the constructor, which will be an item handler, which I'm actually just going to rename to inventory. And all we want to do is override may place, and we're just going to return forge hooks dot get burn time stack and recipe type dot smelting is greater than 0. And that's basically all you need to do. I, however, want to make this a little more customizable, so that maybe instead of just saying this specific burn time for the may place, we could instead maybe provide a custom predicate that we could use. So let's do that. Let's create a private final predicate, and this will just take in an item stack. And we can say, we can call this basically whatever we want really, but I'm just going to call this a fuel predicate. And then we can say in here, return this.fuel predicate dot test, and we can test the stack that we pass in there. And let's create a second constructor. So we're going to overload this constructor, and this overload is going to take in this predicate, and we're just going to set the predicate. So this.fuel predicate is equal fuel predicate. And then this constructor right here, which doesn't take in a fuel predicate, by default, we can just pass in the predicate that we want. So we can say stack forge hooks.get burn time stack recipe type.smelting is greater than 0. And by doing that, it means that we can supply a predicate if we want to. If we don't want to, then it will just use this default predicate, and we don't have to mess with that at all, which is great. And you'll see that in here we are just going to be using that default one, since we don't want to change anything about that. Okay, now that's actually going to be it for the menu for now. Let's go into the screen and let's try and actually render the energy. So what we'll do is go in client screen in our example energy generator screen, and inside of render background we're going to try and render basically like a bar, right, of how much energy has been generated out of the max energy. And this is actually going to be relatively simple to do, luckily. So first of all, we're going to want to get the energy. And that's probably going to be the biggest question, right? How do we get the energy? So you may assume we can get it from the menu. So we can actually do this.menu, which does give us our menu. And from there, you may think we can do get block entity. And then we can say get energy and get energy stored. Now we can do that. However, that's not really ideal, because this may not be synced exactly how we want it to, and it also means we need to go ahead and then calculate the scaled energy so that it scales with our GUI. Now luckily there is a solution for this, and I did talk about this I believe in the previous tutorial, although I may have forgot, I'm not sure. But I believe I talked about it, and we can use something known as ContainerData. So let's go back into our block entity, and what we can do is we can create just below this Oh, actually that's very important too. We need to go ahead and save and load these burn times. So what we can just do inside of here, and I'm just going to hopefully let Copilot do this for me. If tutorial mod data dot contains, we're going to say burn time, and we can say a tag dot int tag. Then basically we can set that burn time to that integer, and we can do the exact same with the max burn time too. And you also want to do that in save, which I forgot. There we go. So do those in there, and that will just make sure those save between like reloads and that kind of thing. Almost forgot about that, and that would have been somewhat catastrophic. Then what we're going to do, so we're going to create this container data, which is just going to be a private final container data. I'm just going to call this container data is equal to a new container data, and we're going to return, in fact we'll give it a count in a second. Let's first do get. So inside of get, what we can do is we can return a switch expression based on the specific index that's passed in. We can say, for example, on case 1, and I'm going to turn Copilot off because it's going to try and do it all for me. What we can say is example energy generator block entity dot this dot energy, right? So that will give us our energy for case 0. For case 1, we may want to use our example energy generator block entity dot this dot energy dot max energy, and I actually meant to say get energy stored there. Then we may want to say on case 2 we're going to get the burn time, right? So dot this dot burn time, and on case 3 we may want to get the max burn time. So example energy generator block entity dot this dot max burn time. And that's actually given us an error because we don't have a default branch. So on the default, we just throw an exception saying it's an unexpected value. And we may actually want to instead give an unsupported operation exception, but it doesn't really matter which you choose. Now set is going to be much the same. We will still switch on the index, but this time we'll just call methods that adjust these specific values. So case 0 for our energy, we can say example generator block entity dot this dot energy dot set energy, and we can pass in p value, and we can say on case 1 we don't want to do anything on case 1, so let's just skip case 1 or go to case 2 instead. And we can say example generator block entity dot this dot burn time is going to be equal to p value. And on case 3 we're going to do the exact same thing but with the max burn time equal p value. And you may want to just validate these instead of just setting that value. That may be something very important that you do. I'm not going to worry about that because it just overcomplicates this tutorial a little bit too much. But just note that you probably should validate these before just setting them, because this is something coming from the client to the server, or maybe from the server to the client. So you don't know which one it's going to be, and you want to make sure you validate that you're getting the correct data come through and it's not going to be like out of range or something. And then finally we have the get count, so we can just return 4 because we have 4 different cases in here. Now all we need to do is go back into our menu. So let's go menu, and inside of the constructor here, specifically the server constructor, we can pass in a container data. I'm just going to call this data to keep it simple. And at the bottom of this constructor, we can just say add data slots, and we can say data. Or alternatively, we can say add data slot. But if we do that, then we have to provide a specific data slot, which is better if you have a singular piece of data. But since we have multiple pieces that we want to sync, we can use a container data, which allows us to sync it all. Now, one problem with this you will see is that our client constructor doesn't have that, and whilst we could get it from the block entity from here, that would just be a little bit of a pain. So luckily we can just give it a new simple container data, and give it a size of 4. And it's very important that you match that size to the size you set here, which is 4. So it's very important that you do match those together. What we can actually do is put these on a new line as well, which just makes that a little bit easier to read. And then what we're going to want to do is make this a variable too. So we'll say a private final container data. Let's set that in our constructor. So this.data is equal data. Then we're going to make some methods that will allow us to access data from that container data from our screen. So we will create, for example, public int get energy. And we can say this.data return this.data.get, and we can provide it with that index of 0. Then we can do the exact same thing for the other ones as well. So public int get max energy return this.data.get 1. Then we can do public int get burn time, and we can return this.data.get 2. And then finally public int get max burn time, and we can provide that with this.data.get 3. Okay, once we've got all of those, we can then create a final method, which will be a public int, and what this is going to be called is get energy stored scaled. And what this method is going to do is it is going to use our energy, and it's going to use our max energy, and it's going to divide them, and it's going to times that by the height or the width, if you choose to have it horizontal, of our energy bar that we display in the GUI. And this allows us to see it scaled to how much it would actually be in size. So all we can do is return, and we're going to have to cast this to an int since we're going to be doing some floating operations here. We can say float, first of all, of get energy, and we're going to divide that by a float of get max energy. And then we can go ahead and times that, ideally actually inside of here, times that by the size of our energy bar in pixels, of course. So I'm going to make the energy bar 38 pixels. That's something I've already kind of decided on before this tutorial. And you can actually surround this in brackets as well if you want to make that a little bit easier to read. Okay, now once we've done that, we can go back into our screen again. So let's go back into our screen. We actually do have an error here first, where we do need to pass in that container data to the menu constructor. And in the screen, we can say this.menu.get energy stored scaled. And that will just get us a scaled value that we can now use to draw our bar. So let's start by drawing a kind of background for our bar, which will kind of present itself as a border. Now, if you want, you can obviously do this inside of the actual GUI texture instead. So by the way, this is my GUI texture. I just have a single slot on the left, and I intend to have the bar about here. I've already calculated the positions for what I want the bar to be at, but you can obviously calculate it however you want. You can have it be like something like that size, you can have it be a slim one like that, you could have it be horizontal, however you want. It doesn't really matter. But I'm going to show you kind of how it will work for me, and you can base that on how it should work for you. So all we're going to do is pguigraphics.fill, and we're going to fill, or I'm going to fill from the left position plus 115, so that'll be my X, and I'm going to new line that as well. Then from the top position plus 20, then from the left position plus 131, so that'll be kind of the maximum X position, and then from the top position plus 60, which is going to be the maximum of the Y. And then we need to provide a color as well, which I almost completely forgot about. The color I'm going to be using is 0xFF555555. Now, an important thing to note about this color is that this is ARGB, so alpha, red, green, blue. So I'll just say AARRGGBB, that's how this hexadecimal color fits. I will leave a hexadecimal color picker in the description of this video. Just make sure that you add that alpha at the front. So obviously FF is 255, so it will not be any transparent at all. Then we can do the foreground. So foreground, and it's going to be the exact same thing, but we're just going to inset it by 1. So we can use this dot left pos plus 116 instead of 115. This dot top pos plus 21. And then we're going to say plus, and in brackets, we're going to say 38 negative energy. And what that does is that will just, so 38 is basically the height of the bar that I'm going to draw, as I've shown you inside the menu, which we also used 38. And then negative, the actual energy scaled would be a better name for this. Then we have the maximum X position, which will just be left pos plus 130, so 131 negative 1, of course. And then this dot top pos plus 59, which is obviously 60 negative 1. Then finally the color. I'm just going to use kind of a reddish, but like a more toned down kind of red color. So FFCC 2222 will do me as that color. Then finally, I want to make a tooltip so that when you hover over it, it will actually show you how much energy is in there as like an exact value. So I can say int energy stored. It's going to be this dot menu dot get energy. So we're just going to grab these values from our menu first. I'll say max energy is equal to this dot menu dot max energy. Then we can create a component that we're going to use. So I'm just going to create this as a literal component. It is not really a good idea to do that. Just so you know, you should make this translatable, but just to make it kind of easier to read for you guys and also easier to understand and just quicker, really, I'm just going to make this a literal component, but you should be using translation components and then you should be appending onto the end of that. But I'm just going to use a literal because I'm not too worried about that kind of thing for me. So we'll just say energy plus energy stored plus, we're going to say slash max energy. So that will just say energy is going to be the amount of energy stored out of the max energy. Then we can just say if is hovering. Now we're going to start from 115. Which, as you can see, is what we started with up here. And we started on the Y at 20. Then we're going to be having a width of 16 and a height of 40. And then we're just going to pass in the mouse X and mouse Y. It is important to note that inside of is hovering, you do not need to provide the left pos and the top pos, because those are already calculated inside of is hovering, as you can see right here. So we don't need to worry about those. And then all we need to do in here is render a tooltip. So we can use the GUI graphics .render tooltip. We can pass in this .font. We can pass in the text, which is this component we created here. And then we can also pass in the mouse X and the mouse Y, which is basically just going to be the position that the tooltip will be at, and we always want that to be rendered at the mouse's position. You may want it to be rendered at a different position, but for us, rendering it at the mouse's position is fine. The final thing to note is that obviously with a literal tooltip like this, you're creating this component every single time this render is called, which obviously if you had like 150 FPS or something, that would be meaning that you're creating this component 150 times a second. So obviously you don't really want to do that, and you would instead have a translation component that you would kind of define at the top of your class up here, and then you would actually append to it only inside of this method using these energy stored and max energy. And that would be a much better way of achieving that than obviously doing it like this. That is pretty much it though, so I think we can test it. I'm sure I've probably missed something. It's highly likely that I've missed something, but we can just test it and find out what works, what doesn't work, and yeah, so I will see you in the game. So as you can see, we're in the game, and I've gone ahead and placed down the generator here, and I'm going to open it up. I'm going to actually replace it down because I forgot to close it. See, instantly we can hover over, and it shows 0 out of 10,000. Now, one important thing to note is that we didn't use the burn time, so we didn't display that inside of the GUI like you can with the furnace. So for example, if you go with the furnace, place it down, you can see the burn time is generated right here. Obviously, if we actually smelt something, you can see, let's just give it like a jungle log. You see that burn time will start to go down, and this is an actual image that it's going to be drawing. We haven't done anything like that, so we're not going to see a display like that, but you can do that if you want to do that. I'm not too fussed about doing it, so I'm just not going to worry about it. But you see that if I grab a coal, or in fact, if I try to put this in here, you see I can't, and you just have to trust me when I say I can't, because obviously you can't see that I can't, but I'm clicking it and it's not working. I'm shift clicking, it doesn't work either. But if I try to put a coal in here, we can see the coal is instantly taken away, and our energy here is increasing. Now, when it reaches a certain amount, you'll start to see the bar will be drawn. So I believe that's going to be about 250, and you'll see we get the first bar. About 500-ish, we should get the second bar, and etc, all the way up to 10,000. And this should only increase basically whilst there is a burn time in there. So it's going to be increasing by 1 every tick, and you can obviously modify that as well if you wanted to. So if you come into your block entity, we just say add energy 1. You could instead say add energy 10, and if we do that, you'll see this increases much faster. As you can see, it's going up by 10 every single time, so that's very quickly going to reach 10,000. Obviously it lasts quite a while having a fuel in there, but we should see it runs out eventually. Might be worth going back to 1 so that it doesn't accidentally overflow. Obviously, if we had a display for the burn time, then we would know how much longer it's going to be. And there you go, you can see that it has stopped. So we can put another one in, and you see it starts again. We can keep putting more in. You see it doesn't like start taking them away or anything. Now, one good thing to try and do is reload the game and see if this keeps running without having taken a fuel out. So let's go ahead and do that. Let's go ahead, save and quit. Let's load back in. And we should be able to see it's still generating energy, and we will still be at 46 coal. So 46 coal, and we're still generating energy. That just means that our saving of the burn time and the max burn time has worked, and those have actually saved correctly. The energy is obviously saved, as you can see, because it's still at the same value, so that's good too. And our items have obviously saved too. And obviously one very minor thing, if you break it, you see the coal gets dropped as well. So that is pretty much it. Well, that is it. So yeah, I hope you guys found it useful. Obviously this is still generating, which is nice. If you did find it useful, please do be sure to give it a like and subscribe. And if you really found it useful and want to help support me, you can obviously join my Patreon as well. If you have any problems, then please do be sure to join my Discord server, which is linked in the description below. And I think that's about it. So yeah, I'll see you guys in the next tutorial, which I don't know what the next tutorial will be. Probably fluids, or maybe it will be sided capabilities. I'm not sure which I'm going to do yet. Probably fluids, if I'm being honest, because it's very, very similar to energy, and sided is like a little bit weirder, so we'll see. I'm sure I'll let you know in my Discord server if you're in there. I'll probably say something in general chat deciding what I want it to be. So I will see you then. Goodbye.